Okay, third try on this one. But that's not your fault. So, um, section two, average atomic mass, mass spec, um, and this is one they do try to work in on the AP exam. But the good news is it's really simple, and it's something that we've talked about kind of as we've gone on. If you've had any physical science class or any maybe a summer class or something where they dug into a little bit of chemistry, then you've probably dealt with this idea of protons, neutrons, and electrons. And what we're dealing with today is the fact that to have an isotope, it's just that there is going to be one or more extra neutrons in a nucleus. Okay, and so when you look at this problem here in problem one, we're talking about neon, and when you look at neon, there's a very common isotope. It's 90% of all the neon on the planet. It's neon 20, which means that it has 10 protons and 10 neutrons. And when you're in sort of the first few rows of the periodic table, you're going to notice that a lot of times the most stable isotope is that isotope that is a double in the nitrogen 14. When you look at the average atomic mass of nitrogen, it's very close to 14. So 7 times 2 is 14. Oxygen, is a pretty reliable 16. There's not a whole lot of other, there are other isotopes of oxygen, but we don't see a whole lot of them. And so, in neon here, it actually has two relatively common isotopes, and then that third one there, sneaking in, there's not a whole lot of it. That 21 just doesn't factor in too much because it's only 0.27 of a percent in the percent abundance. So if I was looking for the average atomic mass, what somebody might do in this case is they might add up the masses and divide by 3 because there are 3 isotopes, and you might even end up getting close. You can try that and see how close that gets you. But what we need to be working on here is a weighted average. And so how you set up a weighted average is you take the first isotope and you take mass times decimal percent. And how you make a decimal percent is you take a percent and just divide it by 100. The quick way to do that is to just move the decimal point 2 places over to the left, making it smaller, and because you are dividing it by 100 to make that a decimal. And then when you multiply it out, your answer is going to work really well. And so you'll notice I put etc. here, and that's because a lot of times there's 2 isotopes, but you might have 3. I've seen them up to 5. They'll probably be on the smaller end when you do it on the AP exam, just for time, because what they're looking on the AP exam is, do you know how to do the problem, not can you keep track of 6 different isotopes. But in this problem, we are keeping track of 3 isotopes, and we're going to look, and this is how that sets up. And so there you see that first most common isotope, and you see that all I did was I took that 90.48, I divided it by 100, or I moved that decimal 1, 2 to the left, boom, like that. And then there's my second isotope. Now, here's a common mistake that people make. When people see that 0.27, they think, oh gosh, that's kind of small enough. And they don't divide it by 100. And you can't neglect to divide that by 100. You have to, every time, divide every percent, no matter how small, by that 100. And so you'll see I have that divided by the 100 here, 0.0027. And then my last one here, and it's 0.0952. Where's that 25? 0.0925. And the thing is here, you move it twice, once, twice, and that's why there's a 0 in front. And then this was 0.27 once, twice, that's why there's 2 zeros in front of that. And then why there's no 0 here is it was 90, and so I moved it twice, and it's 0.9048. And so it's going to be this times this, plus this times this, plus this times this. Now when you put that in the calculator, you can just actually go this times this, plus this times this, plus this times this. And you don't really need to worry about any fancy parentheses or anything, because your calculator is going to want to do the order of operations on that one. And so you're pretty safe to put this in, plus this times this, plus this times this, plus this times this. And when you do it, it spits this out. So if you, and this is my calculator, so if you go this times this, plus this times this, plus this times this, you get this. Now, that's going to be an issue for our significant digits. And when you're doing this kind of problem, the easy way to look at it is, in every isotope, they gave us 2 to the right of the decimal. And so I'm going to round my answer 2 to the right of the decimal, and I'm going to get 20.18 AMU. Now, there's nothing else I need to tell you about that. This is a pretty basic problem. You'll see more examples of that in the handout that I made for you, and we'll move on to some other variations on that problem later.